Hello, today I'm going to explain the practical application of heating effect of electric current. The chapter is electricity. Whenever a current passes through a conductor, it produces heat. Okay, if it is a very good conductor, it produces very small heat, and if it has a resistor, if it is a resistor, then it produces more heat. It is here. So it is undesirable because it converts useful electrical energy into heat. It's okay. So in electric circuits, the unavoidable heating can increase the temperature of the component and alter their properties. So whenever we run TV at our home, okay, when it is running, okay, for more time, it gets heat. The fan even gets heat when it's running for a longer time. It gets heat. Means everything more or less, okay, it gets hot. Sure, but however, heating effect of electric current has many useful applications also. The electric laundry iron, okay, we need to be heated. Electric laundry iron, electric toaster, okay, electric toaster, electric oven, electric kettle, and electric heater are some of the familiar examples of Joule's law of heating. Okay, so these are based on the Joule's law of heating. Now, the electric heating is also useful to produce light. Okay, as in electric bulb we have seen. Yes, here the filament must retain as much of heat generated as it is possible so that it gets very hot and emits light. So it must not melt at such high temperature. Okay, therefore a strong metal with high melting point such as tungsten, tungsten has a very high melting point. It is about 3380 degrees Celsius, is used for making bulb filament. Tungsten is exclusively used for making bulb filament because its temperature, the melting point of tungsten is very high. It is 3380 degrees Celsius. It's very high, it is now. So the filaments should be thermally isolated as much as possible here using, okay, or insulating supports. For example, bulbs are usually filled with chemicals, okay, chemically inactive nitrogen and argon. Nitrogen and argon are, okay, inactive gases, means they don't really, okay, react with others, so they are inactive gases. And this the filling of nitrogen and argon gases in bulbs, it prolong the life of the filament. Means filaments, okay, life is increased when it is filled with nitrogen or argon gases. So most of the power consumption by filament appears as heat, but a small part of it is in the form of light, okay, radiated. Now, another common applications of Joule's heating, okay, is fuse used in electrical circuit. It is a fuse. Okay, fuse, it is very important. Okay, it is a very important application in this electrical circuits. It is fitted, okay, on the switchboards. This prevents any undue damage of wires in our homes. It protects circuits and appliances by stopping the flow of any unduly high electric current. When high current flows through this fuse, the fuse, okay, gets melt, okay, and circuit is broken. Therefore, okay, it doesn't cause any damage to wiring or the circuit or homes. And the important thing is that the fuse is fitted in a series, in an fitted in fitted in series with an electrical circuit here. Okay, and what is the fuse made up of? Fuse is an alloy of fuse is an alloy of it is aluminum, copper, iron, and lead. Okay, alloy of it is aluminum, copper, iron, and lead. This is fuse is made up of an alloy of copper, uh, aluminum, iron, and lead. If a current longer than the specified value flows through the circuit, the temperature of the fuse wire increases. This melts the fuse and protect, okay, and break the circuit. The fuse wire is usually, okay, encased in a cartilage of porcelain or similar material with metal ends. Okay, like a fuse are of fuse for domestic purposes, okay, are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, and 10 ampere. This is important. Okay, for domestic purposes, the fuse, okay, is rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, and 10 ampere. Means if a current in a circuit, suppose if 1 ampere current is fitted in a series, and if the circuit draws more than 1 ampere current, then the fuse will, okay, become very hot. Okay, as a result it will melt and will prevent the damage of the circuit. So fuse, okay, nowadays instead of fuse, this MCB are used. Many circuits, okay, MC breaker. Okay, many circuit breakers are used nowadays instead of using fuse. So MCB also works in the same way. If a large amount of current is drawn in the circuit, okay, it breaks the circuit. Okay, the heat, it becomes hot, MCB becomes hot, and it gets switched off itself because of hot. Okay, it becomes switched off itself. It is. That's okay. So this is all about practical heating of application of heating effect of electric current. Heating effect of electric current. So now, okay, I stop it here. Next, I will do some numerical questions based on this Joule's law of heating.